Hello friends, in our last video we have given the introduction to beams. We have discussed the types of beams, types of loads and also the definition of shear force and bending moment. We also derived the relation between the load, shear force and bending moment. We also saw the sign convention which we are going to use when we are finding out the shear force and bending moment. Okay, in this video we are going to learn how to draw shear force and bending moment diagram or how to find out shear force bending moment values in a cantilever beam, particularly cantilever beam with concentrated load or point load. Okay, so when we see this word beam, right, how do we represent cantilever beam? Generally any book you see it is drawn like this, one end fixed, right, the beam is free and maybe a load acting at the free end, W is the load. This is a cantilever beam. Beam doesn't mean it is having only a line. It's a representation of cantilever beam. But generally if you see a beam, it may have a particular cross section, maybe rectangular, square and so on, circular and so on. One end is fixed. The load will be acting like this: point load, UDL load, UVL load and so on, uniformly distributed load, uniformly varying load and so on. Okay, but to find out shear force and bending moment we need only the length information and the loads that are acting. That is sufficient. That's why we are not giving the cross section. When we discuss bending stress, shear stress, we will be more dealing with the cross section as well. Okay, now let me recollect the sign convention first. What sign convention we were using for shear force? Before that, what is the definition of shear force? You take any section, the shear force at this section is summation of all the forces acting either right side or left side of the beam. Similarly, bending moment, the summation of all the bending moment developed by the forces either right side or left side of the section. Okay, and the sign convention we have, assume this is the section, left side upward is positive, right side downward is positive. I am giving the sign convention for positive. And bending moment to the section, right hand side counterclockwise is positive, left hand side clockwise is positive. So this is the sign convention we are using throughout. Okay, now let us solve, or let us find out, try to find out the shear force and bending moment for this cantilever beam, a point load acting at the free end. Okay, so what you have to do, I am just taking as section X and it is X distance from the free end. I call this as A and B. Okay, now shear force. So at this section X, Vx, V is the shear force. Now follow the definition. Definition is sum all the forces that are acting right hand side of the section. You can also use left hand side. Left hand side, what are all the forces available for this beam? The reaction forces and the moment. So for cantilever beam, if you want to come from left side, you sum all the left hand side or to the section. Either you go this way or this way. Okay. If you are coming this way, then first you have to use the equilibrium equation and find out the reactions. Right. If I am using only right side, okay, then I don't have to find out the reactions. Okay. Now according to the definition, how many forces are there to the right of the section? I have only one force, that is acting downward. Go to the sign convention. To the right, downward is positive. So the shear force is positive W. It is a constant. It is a constant. Right? You take any section, we have only one force. Right? So when we draw the shear force diagram, okay, just draw it, see, a pen perhaps, AB, right, W is the only one force and it is a constant, right, between this W and the fixed support, there is no other force, so it is going to be constant. So constant throughout the length and it is positive, right? That's why it is above. So what is the value? Value is W. At this end also it is W. Okay. So if you just apply boundary condition at x equal to 0, we have W. VB equal to W. At x equal to m, there is no x term in this function, it's a constant. So VA also will be W. If you take left hand side upward, so see the free body diagram and find out W, it is going to be, okay, upward only. So anyway you are going to get positive throughout the length. So the shear force diagram is drawn against x-axis and the load. Okay, load versus x. So this is how you have to plot, and we are not drawing to a particular scale. We don't take any scale and graphically we don't draw. We just represent the we just draw the shear force diagram in order to understand throughout the beam at any section what is the shear force value. Okay. Now we will move on to the bending moment, in short BM, right. I have taken the section, same section, x distance from free end, and what is the definition of bending moment? It is force into perpendicular distance. I have only one force to the right of the section, that force is W. It is going to produce clockwise moment about this point, okay, through which the section is passing, and see here, right side anti-clockwise is positive, so here it is clockwise, so it is going to be negative W into, I am taking only at this section x distance from the free end, so it is W into x. When you have x, the function is a linear function, right? Now when you see x, you can apply the boundary condition. What is the boundary condition? At the end, at the free end, at this fixed end, okay? So at x equal to 0, m b equal to 0. Yes, you substitute 0 for x, then you get 0. At x equal to L, we are at A, so minus W L. It is negative. So now I will draw. So I can just, if you see the books, they also hatch it. It is nothing but, it is the shear force diagram. Now I draw the bending moment diagram. AB, at B, 0, at A, W in the L, and the variation is linear. So I have to draw, sorry, it is a straight line. And it is minus, what is the magnitude? W into L. Here also you can hatch, even you leave it, not an issue. One more thing, we have already saw a relation dm by dx equal to V. So the shear force value will give the slope for bending moment diagram. What does it mean? The shear force value, or seeing the shear force diagram, you will get some information, the slope information to the bending moment diagram. When it is a straight line, the slope is constant here, constant here, constant here. Throughout it is constant. You can take the slope, it is constant. So that is how we get the relation between shear force and bending moment using this small expression. We will move on to the next problem now.